closer feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Kahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Morty the Rabbit, and more. Super Statistics Bros.
I can edit a video, but I don't know how to put on a microphone. We weren't muted. We had no microphone there. I was like, wait a minute, I'm not even wearing a mic, so you can't even hear me. So I was saying, good to see everyone here. Good to get started. We're no longer muted. I can see the levels bouncing on the audio now. Thank you, Hannah and Malone right there. This will be uploaded. It's all uploaded. It's all live, so you can watch it at any time now or later, like candy. So check it out when you want. It's currently live, but you can watch it later. Petrie has uploaded an amazing video showing you how to do the mock exam.
Let's watch option.
So I would highly suggest going through, watching this video right here and checking out how to do it. Make sure to have your notes, make sure to load the mock exam and watch this video. If you are in our class and you're going to take the computational exam, you should know how to load it in. How are you going to know how to load the mock? How are you going to know how to load your exam? So what should you do today so that when it comes time for class, either Monday or Tuesday, you can do the mock, you can do the real exam. Watch the video, go to the mock exam right here, download it, see how it works, understand what's going on, look at the questions. And I want to point to something even more too, that when it comes to the midterm, you'll see right here, this is amazing. I just want to like zoom in on this for you, but look right here. One question using the left arrow repeatedly updating a value inside of a variable. Did any of your homework assignments have you do this? If I was making my file, I would put in this question, or I would say like, here's how to do this. Make your file, your notes file, and look at each one of these questions that is very specific on what you will need to do. One asking you to use and or one having used percentile and percent, which is contained in. You can go to ChatGPT to help you make your file. You cannot use ChatGPT during the test. So you should have created an R file for this and start working on it now if you haven't. But I've been begging people in my class to create this R file, to keep updating it, put things inside of it, and your homework assignments are going to be a huge help. Now, when it comes time for the conceptual, Petrie couldn't have been more clear right here on what is going to be covered. Take a look right here at what is covered, choosing an X and a Y. So think about a question that would be something like, if we were predicting someone's college GPA from their high school GPA, well, darn it, I just said it. What would the Y variable be? I literally said it. If you listen carefully, I actually said what the Y variable would be. I said college GPA in high school, so which is the Y variable? This is the test. This is the test. This is everything. College GPA, and I said predicting. And so if you hear me say we're predicting, the test isn't that nice. But when you say predicting, we are predicting Y with X explaining it. interpreting a mosaic plot. Do you suspect an association? Comparing marginal and conditional distributions. So you should understand all of these and the associated output. There's a lot of things covered, a lot to understand. If we just choose a random letter, and I'm just going to go into detail. Then we're going to start the Kahoot next. But choose a random letter on this screen and just tell me to go into some detail on it. And a lot of these, a few of these covered. S2 says, look at a residual plot, residual versus predicted, and identify which assumptions are violated. So when it comes to a residual plot, let's take a look right here. We're going to pull up the 2 hours later. And we would need a model to do this. So we are pulling up a residual plot. One moment right here, we will have one up and going. I'm going to close out of all these documents. Don't save any of those documents. Here we go. Oh, let's zoom out. So what we got to do is we got to load up reg class. And there's my reg class library. I'm going to go data survey 10. And then we go here into M, save into LM, weight, comma, height. Data equals survey 10. We're just making a quick regression so that we can check the regression. And with the check regression, what conditions are violated or not violated, and how badly? How do you know if conditions are violated in the check regression? This is what S2 would cover. How would you know how would you know to start if conditions are violated? Talk to me in the chat, give me some hints, and then we're going to start the Kahoot right after this one. And I will say this, every lecture, every walkthrough should cover these. So have good notes, like take good notes on each of these and know how to do it. If the PI is below 0.5, Christopher, great answer right there. You are right. The condition for linearity is failed. Now, linearity of the X and the model are the same at this point. So linearity is failed. Same thing that has failed for the X and for the model. We also have normality of residuals is failed. And that is a huge problem over here when you look at the residual plot. So looking at the residual plot, it's not minor issues, it's major issues, especially out here. Low outlier on the low side down there. Huge problem up here with big outliers and a pull towards the skew. I guess that's a little bit of right skew because of the high nature, longer tail on the right side. So overall, the linearity, actually, I do see a swoosh. You notice here, it starts out above. All these points above is a problem with the linearity because you want points equally spread out above and below. Equal would be the equal spread, but you want them above and below. You don't want all points above because then that's a problem for the linearity. So I see a problem of linearity at the start in this plot. This is not the linearity plot over here on the right. This is only to check what? I can't state this enough that the only thing this plot is looked for and the only thing this plot is looked at for is to check what? Now, I don't look at histograms usually. They're not a good way to evaluate this. This plot and this plot are only to see if what's are what. Residuals are normal. You look at the first one for linearity and equal spread. And was it, yeah, linearity failed and we passed equal spread. But the linearity of the model can also be seen as a problem by the visualize. And you can see that same swoosh nature and the outliers causing probably the normality problems. So lots of things right there. Maybe we'll do a little bit more at the end, but you know what time it is. Let's put right here, let's say, preparing for the test. And now at 9 minutes and 53 seconds in, time for Kahoot. Let's go over here. Let's get that Kahoot music going. Who's ready for some Kahoots? I need some I'm ready's in the chat as I lose my mouse over here. I need some I'm ready's. We got Kahoot in the background. Let's get the music up a little bit. Get over to our disco music and keep it to there. And we'll go over to disco. Oh my God. Dom's right. I like it. Okay. We got Royal Sphinx in. How many people we got watching? We got like 20 watching. How many we got watching? 30 watching, so we should get at least 20 in. Sent it out on the class and sent it out on the everything, on the Discord and all that good stuff. 34, thank you, Major. Okay, this Kahoot has been tailored to help you learn the material. Look at the volumes on the music. Pretty good music volumes. There we go, I like that. Chill in the background. We're gonna give this about 30 more seconds, so make sure you're here and joining because we got 26. I'm gonna put on a 30-second timer, then we're starting. 30-second timer on. This is 320. I put 320 in the title, right? Even though I did 201 start. So Major, you can play even, no matter what class you're in, you can play. What's up, Thomas? Good to see you here. 100 points for Thomas swinging by. Thomas, good to see you. Thank you for swinging by. Honest Kitten, looking like a... I'm sorry, I will not X you out of the Kahoot. Okay. Last time readies. We're starting in 5. I need some memories in the chat. 4, 3, 2, 1. Here we go. Hannah's ready. Let's do this. First question of the Kahoot. Let's do this. Hopefully I didn't make any mistakes when I was updating questions this morning. I hope. Mine's ready too, and Thomas. First question is, state your conclusion about the QQ plot. QQ plots are known as quantile plots. So when we do a quantile plot, what are we looking at? What are we trying to understand? We'll always read the bottom of the graphic if you're trying to understand, because usually we give extra information. QQ plots, as we just mentioned a moment ago, have nothing to do with linearity. So the blue and the green answer are wrong. The only point of a QQ plot is to analyze normality. It's also known as a normal probability plot or a normal quantile plot. We call them QQ plots for quantiles of the normals versus quantiles of your data. This is what we expect if normal, and what we see in your data. So where the two line up creates a what? What you expect in the normal versus your data, where they line up creates a what? Where like 2.5 is and 2.5 is here. Like if you go over there to 2.5 and go down to 2.5, you can see a what where they intersect. What do you see where 2.5 or like where 3 is at up here and 3 is at down there? We have a what? It's not a linear relationship. What do you see? Like if you trace up to 2.5 and hit this, and you go over to 2.5 there, everything that intersects at the same value of what you would expect on the normal versus what you see in your data makes that red line. Now the dots are your data. If your dots, it's not quite a residual zero. That's not a residual zero though. This is not the linear model. This is saying your residuals follow the normal. So the red line, and it could be considered a residual from the normal. Like how far does it deviate from the normal? I guess you could do that, because kind of right, Chris, 50 points right there. It would be, does your data follow the normal, and things that deviate have like they're below what is expected given the normal. It's not quite a linear model, so I would kind of go away from that interpretation a bit, even though it does work. We'd be saying this data right here, and let me ask you, should we use means or medians? This is a famous question for this. This one is a fairly obvious answer that most statisticians, I would say 90+% would answer. What way? Means or medians? Means. Great job, Riley, right there, or Adam and Hannah. Would use means. What you want to look for to use medians is probably, I would say, 2 issues. I would, or a major issue or 2 moderate issues. So I think that's when you start, and I don't see really any issues here, because the dashed lines are your like, meh, nothing's perfect. And I think this was actually generated. No, it's from the attract data set, it's score. I thought it was generated from a normal, because this pretty much follows the red line. The dashed lines are your meh, like it's okay. You'll see ones worse that really have deviations or large outliers. If you see points way down here, or you see points that start to deviate a lot, that's when you go towards medians. Read the answers in depth. Think about how you would read this. My answer for this would be, I would use means, since the majority of the points follow the normal, and we don't see large deviations on either side. There's small deviations on the low side. One point that is far away, but it's within the bounds of what we would expect, plus or minus a little bit. On the top side, the same happens. There's a little bit of weirdness, but it's in the bounds of what we would expect. The kind of the leeway is the lines, the dashed lines. Great work. Let's see who's in the lead. Let's check it out. And the leaderboard is Funny Emu. Great job right there. Tied with Honest Kitten and Hero Owl. Snowman looks like. Next question. Let's do this. Compute the expected count for Verizon rarely. 30 seconds on the board. Row total times column total over grand total. A lot of people forget how to do this. Answer if you don't have an answer. Take a guess. Remember, you don't get points for wrong, or you get points either right or wrong. So guess. But have your calculator out. Now, this is a reminder to grab your calculator, and then we're going to show how to do this. Remember, if you don't answer, you don't get points. So you need to answer even if you can't. So I'm like, please answer. Okay. Quite a few people got it right. How do we figure out expected? How do we figure out expected? And there'll be a chance, grab your calculator, there'll be a chance to redo this. How do you figure out expected? Don't worry if you got it wrong. Focus on how do you do this. So this is what we see in the data. How do you figure out expected? How do you figure out expected? How do you figure out expected? This is a contingency table. Row total times column total over grand total. Row total times, so the equation is RT times CT over GT. And it said Verizon, rarely I think it was. So Verizon, rarely. And so we take this times this over this. Does that make sense? So it'd be 437 times 310 over 579. Does that make sense to people? You kind of look where things crisscross, and then you figure out the row total, which this is the row total, and this is the column total, this is the grand total. So you do row total times column total over grand total. The thing is, make sure to have your notes on this. Make sure to write expected equals row total times column total over grand total. And if you have your calculator out next to you, just start punching this in to remember how to do it. I can't state this enough. The things you see me doing, try doing yourself. Try drawing out something like this. Try solving it, creating that muscle memory in your brain on how to solve these. Because on the test, you can have one sheet of notes front and back. So if you have the equation written down, row total times column total over grand total, you just need to know where to get those numbers. Does that make sense? Row total is across the row, Verizon right here. Column total right there, and grand total. Now this can also be described as the amount we would expect if there is no association. What did I just say? This is the amount we would what if there is no association. This is the amount we would what if there is no association. Jad, good to see you there. This is the amount we would expect. Now it's not the percent we would expect. What percent of Verizon customers would be expected to have rarely dropped calls if there is no association? I'm purposely asking these questions. So the question is, what percent, and I'll even put it in the chat, what percent of Verizon customers would we expect to have rarely dropped calls if there is no association? What percent of Verizon customers would we expect to have rarely dropped calls if there is no association? There's the question in the chat. And I don't know, 33%. Good guess, Evan. So this is a tricky one. It might be 63. That is maybe Adam Petrie has it. I was thinking it might be a little higher. So 100 points, Dr. Petrie, and I do not know why. Dr. Petrie, I thought you were a mod here. Double, just in case, because it is a random stream. I feel like this is Dr. Petrie. So I'm gonna go on a limb. He got the answer right, and his name is Adam Petrie. So with that right here, let's think about what it means to say if there is no association. If there is no association, all the data in here wouldn't matter. Does that make sense? If there is no association, good to see you there, Dr. Petrie. If there is no association, all the data there wouldn't matter. Does that make sense? Who follows me on this? If there is no association, all the data there is, for some reason that shrinks, wouldn't matter.
It doesn't matter.
And so with this in mind, we're looking at the what display currently. If there is no association, we're just looking down here at the what display. What's that called? If there is no association, we're now just looking at the what display. If there is no association, we're now just looking at the marginal display, which is what percent of people have rarely dropped calls. So the answer is going to be, to get that 0.57 right there, is going to be this over this. It's just, if there's no association, then the Verizon customers would have the same dropped calls as everyone else. The inside of the table gives conditional distributions, which say given someone's a Verizon customer or for Verizon customers, what's the percent of dropped calls. We can compare the conditionals to the marginals to see if there is an association. And the bigger the difference is, the less likely by random chance that that discrepancy is observed, as in the discrepancy. We'll be looking at this here shortly with some more in-depth questions. And I can't state this enough. I got to give another 100 points to Dr. Petrie, because when you look at the breakdown of the test, it literally tells you what's on it. I cannot prepare you more than enough than what's on there. And the questions you're seeing right here mimic what you see in the full alphabetical order. So take a look at what's there, try to come up with example questions, and then try to look at how this Kahoot mimics those questions and gives you possible questions. So with this, let's go to the next question. Prairie Turtle, Quick Eagle, and Agent Fox in the lead. Next question. Side-by-side box plots compare categorical X, quantitative Y, and oh my gosh. What would you use on this? I didn't change the question. Sorry, I was like, I thought I changed this. Would you use means or medians for this? I think that's the only error I have. Let's hope this is the only error. Would you use means or medians? This has nothing to do with side-by-side box plots. Well, it could, because you can look at the quantiles for each of the groups. Means or medians. Sorry for the title at the top. I think it's the only one I made a mistake on this morning. Means or medians. Means or medians. Good work. And why did you say that? Talk to me in the chat. Why did you say that? Why did you say that? I think this is the one very special graphic. So it's got skew. And remember how I said, so if you remember earlier, and great job, Miles and Dom right there. So it does, so there's down here, Dr. Seaver always had a strong graphics. And so I said, if there's one major issue or two moderate issues, I'm giving you the advice to go with what? If with a plot, there's one major issue or two moderate issues, I'm giving you the advice to go with what? One major or two moderate? If there's one major or two moderate, kind of, yeah, that is correct. This wouldn't be, this is not Spearman Pearson right here. You're kind of on the right track, because Spearman deals with issues that for correlation where we would use Pearson. So Owen, good answers right there. And this wouldn't be an analysis of using Pearson versus Spearman. This is a QQ plot for normality, known as normal quantile plot. And what I'm doing here by color coding it is, I think the most major issue here with this is what? Help me out with explaining to me. The most major issue is with the what right here. By the color coding I've done with red, orange, and yellow, the most major issue to me is probably that what? The most major issue is probably that what? Well, the S shape, the outlier, this outlier here at the top of it is probably the one like, and it could be even worse, but that right there might be enough for us to say, let's go with medians. Like that's a problem. We don't want that, because outliers greatly influence the mean. We got a problem right here. But then on the low side, we got some pull away from the normal. That was marked in orange to be like, yeah, that's not that good either. I mean, if there was just that, I could maybe let that fly, but it was on both sides, because that's the two issue thing I'm talking about. And then that S shape, so we got like a major issue, a moderate issue, a minor issue. And if there's no issues or tiny issues or small issues, we go with means. But because of the outlier, the deviation on the low side, and a little bit of an S shape going through what we would expect normal, I am using, say it with me, what to compare measures of center. So because of the extreme outlier and a pull away from the normal on the low side with a weird looking S shape, we're going medians to compare measures of center. Now remember, one major issue, two moderate issues, or maybe a bunch of minor issues. Don't look too hard at them though. Things should jump out to you. So if you see, think, is there something I see big? And remember the first plot we looked at, which was means. So if it looks really good and there's only little things, like little tiny, like if the rest of these points at the end, like if down here, Like, take away that right there. Why do you think I'm doing this right here? Sure. This, yeah, I wonder what Petrie would say to this, but I think that's good enough. It would change it. At this point, you could maybe get some statisticians to disagree, but there's some weirdness, but you're definitely leaning more towards means at this point. So probably this might branch to means. I still don't like that SE curve to it. That's not that great, but I can probably forgive it enough and try to look for things like we really only have at this point that SE curve, a little bit of weirdness here at the end, and that's it. So I'd say 2 minor moderate, and that's an iffy one. So, but look for bigger things. I wish we had you highlighting it. But at this point, I'd probably lean towards means right here. I wouldn't menace when they use medians, but medians is always the safest one, but you want to find issues and you want them to be bigger issues. Would the change in the data points change the dotted and the red lines? Probably the way they're calculated, because the red lines are the distribution of points given normal. So it would change those bands, and it would probably change, I mean, the z-scores are still going to be the same on the density of the points within the quartiles of the normal distribution. That's what a QQ plot stands for, the quantiles of the normal versus the quantiles, and quantiles are quartiles, basically. So it wouldn't change too much, but it would kind of update it a little bit. And yeah, here we go. There shouldn't be any more problems with the questions the way I wrote them. Hopefully not. Prairie Turtle, Royal Sphinx, Funny Emu, Honest Kitten, and Agent Fox. Let's do the next question. How would you interpret a prediction interval using predict M? Now, this is very important. This is the predict M. Predict using your model, comma, new data equals data frame, comma, interval equals prediction or confidence. So you need to understand what a prediction interval is. Knowing what your output is very important. I should have told you, or should have put a prediction interval on here. But when we do prediction intervals, what are you predicting for? A prediction interval from the predict M output. Good work. Prediction intervals are for individuals. For individuals. When would you get intervals predicting the slope? And when would you get intervals predicting the intercept? Great job, Jeet right there. When would you get intervals predicting the intercept and the slope? And it's important to know that we don't talk about like a chance of them being contained in there. We say, you know, I'm 95% confident. I have this level of certainty. But it's not like a chance, because it's either in there or it's not. There's just a fact of the world. It's not like we're rolling dice and we got a chance of it being in there. There's just a certain confidence we have. And it's actually confidence of the law of large numbers that over repeated trials, repeated intervals, 95% of 95% prediction intervals would contain the individual. And so it is, well, and it's confident. Good job, Maya, right there. The code we would be looking for the slope and the intercept is confident. Confident is confidence intervals for your model. And the confident makes a confidence interval for the slope and for the intercept. With the predict, you can get prediction intervals for the mean of the line, which is the line itself, which is the tighter interval. And you could get prediction interval or confidence intervals, excuse me if I misspoke, a confidence interval for the mean of the line and a prediction interval for individuals. It's very important right there to know predict gives you confidence and prediction intervals for the line. And also confident gives you confidence intervals for the coefficients in the model. Right now, the slope and the intercept, B1 and B0, slope, intercept. Okay, let's take a look at that leaderboard. Prairie Turtle, Funny Emu, Happy Quail, Honest Kitten, Agent Fox. Next question. How do we interpret the intercept? Really good stuff right here and a lot to read, so be ready. If you know how to interpret the intercept, you know exactly what to look for. Remember, answer, no points if you don't answer. This is a general interpretation. It's about knowing what goes where and knowing your notation. See what people say. What is the intercept in notation? No worries. What is the intercept in notation? What is the intercept in notation? So just tell me the notation of the intercept right now. What is the intercept in notation? What is? Not beta. So kind of, yes, that is true. Riley, I got to give points for that. Beta 0 or beta naught, I usually call it beta 0. Beta 0 is the true intercept. The estimate of the intercept given by our model is B0. Beta is the truth, which we probably never know. This is what we call B0, an estimate of the intercept. So when you're narrowing these down, you'd want to look at the ones that only have B0, because B0 is the coefficient of the intercept. Think about it. If you look at your model and you go here, the line hits the y-intercept when what is what? The line hits the y-intercept when what is what? So the line hits the y-intercept when what variable is at what value. So the line hits the y-intercept when x is equal to 0. So that's what we're doing right here. When x is equal to 0, or among individuals with x equal to 0, we would expect y to equal b0. You don't want to say words like will, because the line just makes a prediction. You have to watch out too, because intercepts can be illogical or extrapolations of your model. So with this right here, the proper interpretation is among individuals with x equal to 0, we would expect y to equal b0. So, and this is like an on average because it's expect, it's not saying will, it's a prediction from the line for on average for those individuals right there, because the line is the average of the points. So here's the thing. Do you get a cheat sheet? Do you get a cheat sheet? Yes or no in the chat right now. Do you get a cheat sheet? Do you get a cheat sheet? If so, you do. You get a front back cheat sheet. Write this down. This, as long as you're in Petrie's or my section, I can speak to our sections. You do. Check with your instructor if you're not in our sections. Write this down. You can pause the screen. You can write it down. You can come back to this later. So front back cheat sheet. So make sure to have this written down. Know how to use it. Check out the page. If you're in our sections, check out the page going over what you can use for these and what you can't use. Can't use ChatGPT, things like that. You can use it to prepare. Can't use it during the exam. Check out the pages right there. While we're here to help out, Adam, thank you so much. Let's do the leaderboard. We got Happy Quail, Funny Emu, Honest Kitten, Agent Fox, and Prairie Turtle. Next question. You know it. Interpret the slope. Same sort of thing. Knowing your notation is going to be huge. After you're done with the question, write it down. If you're looking for the slope, you should be able to narrow it down to just 2 choices, because you need to know what is the coefficient of the slope. Coefficient of the intercept is b0 when x is equal to 0. We expect y to equal to b0 on average. But the coefficient of the slope is b1. Now be careful. We don't want to make it sound like cause and effect by saying if you increase x by 1, y will increase. That is horrible. What we want to talk about is 2 individuals or 2 things or 2 whatever the context is. It's not always individuals. I should clarify that, because maybe we're talking about 2, I don't know, I can't even think, 2 states that differ in their population size by 1 person. And you can change the coefficient or the interpretation by multiplying by 1,000 to be like 2 states that differ by 1,000 people. And then if it was calculated by 1 person, you'd have to multiply the coefficient by 1,000. 2 Frenchies that differ in their weight. But Frenchies are individuals, aren't they? 2 Frenchies that differ in their weight by 1 pound are expected to differ in their daily food consumption by 0.2 grams, where the Frenchie that weighs more is expected to eat more. So listen to that again right here. 2 Frenchies that differ in their weight by 1 pound are expected to differ in their daily food consumption by 2 grams, where the Frenchie that weighs more is expected to consume more. Oh, good deal. God, awesome to have you here. So the key is these expected or predicted words are very important. I'm going to disappear so you can see this. Write this down if you don't have it. I am also limited on character words here. I think basically maxed it out. It literally went to the period. Like, do I need the period? And I'm like, well, there's, and I was going to put by Y units. But 2 Frenchies who differ in their weight by 1 pound are expected, 1 pound of, which is X, are expected to differ by their food consumption by 2.2 grams. I'm just making that up right there. That's a fake equation where the coefficient of B1 is 0.2. Now, I do want to point this out, and let me head over here. What is the value of B1 for this model? So start typing B1 in this chat. You have to know what B1 is in this model to interpret it. Like two individuals who differ in their height by 1 inch are expected to differ in their weight by about 5 pounds, where the individual who's taller is expected to weigh more. Well, I said it while we were doing it, right? So it is 5. Make sure the positive or negative. The intercept is an extrapolation, also in a logical value. So it really doesn't have any practical interpretation. I would say it to someone if they asked. And they're like, but come on, interpret it. I would say, okay. Among individuals who have a height of 0, we would predict on average that their weight would be negative 178. And that really doesn't make sense because you can't have a height of 0 and you can't have a negative weight. So this is an extrapolation of the model right there. So once again, know where B0 is. It is the estimate of the intercept, estimate intercept. Know where B1 is. It's the estimate of the slope. Know all your output, everything on the screen. Check out the videos where we go over it. We'll be doing more here in a second. But for now, the leaderboard. Leaderboard right now, Happy Quail, Honest Kitten. We got prizes for first, second, third. We got $20 for first, $20 for second. We got Kahoot t-shirts for everyone we can give them out to while we still have them. Swing by my office if you win. I might have limited sizes. You could give it to a friend. You could keep it. It could be a night t-shirt if it's a triple, quadruple, 5XL. I do not know. But if we have a t-shirt for you, swing by and I'll tell you what sizes we have and all that. We're pretty limited right now on sizes though, because I've been giving them out. So first, second, $20 Amazon or Starbucks gift cards. Kahoot t-shirt goes hard. Let's check out that next question. What words describe this scatter plot? Ooh, I'm excited. I was actually wondering if Petrie would agree with me. He's out. No! Petrie, one more. Hopefully I didn't get this wrong. He's free to leave though. What size t-shirt is this? It's a medium. We'll see what Petrie says, but thank you, Dr. Petrie, for swinging by right here. Select all that apply on what words describe this scatter plot. I can't see him disagreeing in any way. The only thing that this doesn't have is homoskedasticity. The only thing it doesn't have is homoskedastic. When you break down the word heteroskedastic, skedastic means spread. And what does hetero mean? Heteroskedastic. And you can see it right here with this. You can see it go blah, 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 blah. What does heteroskedastic mean? Hetero. So look in here where it's like this, and then it starts to go more and more and more and more. Not a curve. So hetero means different, and then skedastic means spread. What does homo mean? You got homoskedastic and heteroskedastic. Homoskedastic means same spread. A homoskedastic relationship has equal spread across, where a heteroskedastic relationship has differing spreads. Heteroskedasticity, spelled with a K or a C, points to a differing of strength of the model, which is what we don't want, because we want the line to have a consistent equal strength, not thickening, Stat Tool 1 lingo, throughout the model. So that is heteroskedastic. Now, nonlinear means there's a bend. So something is either linear or nonlinear. This has nonlinearity because it starts to curve up, and you can see it starts to level off down at the bottom right here. So especially if you go up here to the point here, and you notice if you were to plot downward, you can't really make a line. So to test to see if something is linear versus not linear, always think, if I put a line through the data, would the line need to bend to do a better job? To some degree, that would help it in a lot of ways. And you see, you can't really put a good line through this data. The best line through this data is going to look something like this. And take a look. At the start, the points are where, and then towards the middle, the points start to go where, and then at the end, the points start to go where again. And this is a huge indicator of non-linearity. That's the big indicator. When you draw a line and you see that what the data should, or the model should do, is something more like this right here. The line should be the mean of the points. And you see that there is this kind of bending of the data. And so the linear model would not be appropriate here due to the non-linearity. What does monotonic mean? What is it's your favorite band? Mary, favorite band? What's your favorite band? This is extremely monotonic. What does monotonic mean? One direction, 1D right there, one direction. So monotonic means one direction. At all points, we can do the proper form right here. at all points, this model goes what? Why is it 1D? Strictly increasing or decreasing. So at all points, the model's going in a downward fashion. So because it's going down, that is one direction, nonlinear, heteroscedastic. So very important to understand each one of these terms and write down a check right here. Check for monotonic. At all points, does it go in one direction? Or for the majority, the vast majority of the data goes in one direction. If you have one point that goes a little bit weird, the vast majority of the points goes in one direction. Homoscedastic. The points have equal spread throughout. Now, it can't be homo and heteroscedastic because they're contradictory in terms. Linear, the majority of the points follow a linear relationship. Nonlinear, the majority of the points, or there is a strong nonlinear trend indicated in the data. I think that's about it for the terms. Write down a definition for each one of these and then how you will check it. Cheat sheet. Kahoot t-shirt, but cheat sheet. Write down nonlinear. Is there a bend that is going through the data? Homoscedastic. Do the points stay about equal spread? Heteroscedastic. Do the points have a differing spread throughout the model? Monotonic. Do they mostly go in one direction or do they go in a bend direction right there? Woo! Excited. Let's look at that leaderboard. Happy Quail. Good job. Honest Kitten, Prairie Turtle, Funny Emu, and Asian Fox. Next question. Which conditions are failed? Get ready to check the boxes on the conditions that are failed. I'm like hoping I didn't make a mistake right here. Someone's like, look at a question, update it. So when you're doing the null hypothesis for these, the null hypothesis is linearity is good. The null hypothesis is equal spread is good. The null hypothesis is normality is good. So low p-values are bad. Since low p-values are bad, only one p-value is low. And the p-value that is low is linearity. So how do you check? And there'll be a second chance at this. When you are checking conditions, how do you know if a condition is failed? By looking only at the p-values. You get your first idea if conditions are failed and looking at p-values on the check regression, you know a condition is failed if what? So write this down. These are the things to write down. When looking at check regression output to know if a condition is failed, Maya said it right there. And protect the bill. So the null hypothesis again is that linearity is good. So when you reject the null, you're saying you have evidence linearity is bad. People are like, but I thought low p-value is good. Well, if you want evidence for the alternative, yes, but it depends on the context. If the context is the alternative is that linearity is bad, it means you got to probably investigate or fix up your model with a fine transformation. So at this point, we would have evidence of only problems with linearity. And from here, we would look at the diagnostic plots because the sample size is 25 or greater. So due to the enough data to get statistical power to investigate this, we should give it a second look and see how bad is the linearity. Huge note, once again, we're talking about the notes you should have on your sheet when doing a check regression. And so try to write the full thing here, and great job, Maya and everybody practicing. When doing a check regression, we know that a condition is failed, and this is only for these check regression p-values when a what? When doing the check regression, which checks the conditions on which our regression is built. Do we have linearity? Okay, do we have that? Okay, we don't. Okay, do we have equal spread? Okay, we do have equal spread. That's a good thing. Do we have normality? Okay, we don't have reason. I should talk statistically. We do not have evidence to suggest that there is non-normality of the residuals. We will continue to believe due to the high p-value. A p-value less than 0.05 and the condition is failed. You give it a second shot by looking at those diagnostic plots. So own good work. Keep taking those notes on your sheet so we can get ready for the test. Next question. Let's do this. Happy Quail, Honest Kitten, Funny Emu, Agent Fox, and Champion Badger. Here we go. Which values require extrapolation? Now remember, extrapolation is where we don't have data in the model. Oftentimes extrapolation can be at the start or below the start and beyond the highest point. But extrapolation can happen within the model because we don't have anything nailing it down. So that's kind of the trick right here. Extrapolation can happen within a model, within a bounds of x's where you don't have data. And so we think sometimes, wait a minute, we're confused. We don't know what happens in this region because there's no data to confirm the model. So the big one people might have missed right here, or did I forget to click it? I don't think I did. Oh, did I not click 300? Oh my gosh. Okay, I got one thing wrong right here. I'm sorry if this hurt people's score. I don't know why 300 wasn't clicked. 300 is a correct answer. Brian made an error. Very sorry. Hopefully this doesn't mess up people's scores too much. But why would 300 require extrapolation? 300 is a correct answer. Hopefully the test doesn't have errors. I forgot to check a box. Why would 300 require extrapolation? You are correct. Very sorry for anybody who missed it. I mean, you got it right, but so not shown, it is beyond. So we don't really know what happens in this region because there's no X's, and we don't know what happens outside of here because there's no X's, and we don't know what happens down here because there's no X's. It's beyond the bounds of your X's. You have data within here, so that is a non-extrapolation zone. And it's kind of a matter of degree because it's not like here is a big extrapolation, or I kind of did a little bit beyond the X's because the X's kind of have a little bit of, I would say, understanding slightly beyond them. Technically, anything beyond any X is an extrapolation, but I purposely chose a data model that looks like this to show there's a big unknown region in here. At this point, you would definitely be hitting a much larger amount of extrapolation. At this point, I would say at 125, I chose about the middle of here, is a very uncertain zone. Going further out from it, you'd have less extrapolation the closer you are to your X's. And so you could talk about the degree to which you're extrapolating. And so at some point when you get close enough, it's a light extrapolation, but you're extrapolating beyond the bounds of your X's right there. And you'd really hit a very unknown region. So the more outside or away you are from any X values, the more of an extrapolation you are doing. And huge thing, extrapolation can happen within the X's. So once again, give some big tips. Extrapolation can happen within the X's. So make sure to check off that 125 because it can happen within the bounds of the X's. Okay. Happy Quail, Honest Kitten, Funny Emu, Ancient Fox, and Champion Badger. Next question, let's do this. The model used as a starting point to compute the sums of squared error is the what? What do we call this model? Has a very specific name. Who knows? So the SSE of a model is the sum of the squared error. The regression model is the line, the y equals b0 plus b1x. The RMSE is the root mean standard error. I think I might to write right there. That's the typical miss the model makes. And the naive model is the mean of the y, the naive. The naive is the starting point by which we compute the sums of the squared error. So this is the starting point. It is not our model yet. It is the total sums of squares that exists right there. So the model is called the naive model. The SSE model is not really a thing. There's the sums of squared error. So the naive, let's say you were to predict people's height, what would you predict a random student's height to be? What would be a good prediction of a random student's height? What would be a good prediction of a random student's height? 5'6", it could be. You'd go right here and you'd go to survey 10 and you'd go height and you'd guess about 5'7", 5'8". Does that make sense? There it is right there. The average height of all students, there it is. That would be your prediction. You want to predict the weight of a student. There's your prediction right there. And that is the mean of all students' weights. So that would be the starting point by which we compute how much error there is in the y. And then we would try to reduce that error by creating our model, the naive model. Very important concept. Leaderboard time, Happy Quail, Funny Emu, Agent Fox, Honest Kitten, and Expert Wombat. Next question, let's do this. Which of the following is not a condition for regression? So think about those conditions that we've gone over. One of them is slightly a condition because we should say that the residuals should be independent of each other. But when we talk about the conditions that are checked with check regression, there's three major conditions we are checking. And a quantile, normal quantile plot will pretty much check this because you wouldn't see patterns if it's random. So although random is on here and randomness is very important, random is not one of the conditions. Linearity is checked that our model follows a linear pattern. Equal spread, the points have equal spread throughout, plot doesn't thicken, and normality of residuals deals also with things like outliers. So basically we're doing QQ straight enough, no outliers, plot doesn't thicken. QQ means two quantitative variables must be used to do a regression. Straight enough means it's a linear relationship. No outliers is checked to be normality of residuals, and plot doesn't thicken is equal spread. And if the residuals aren't random, it's not a condition we really look at, but it would be seen in probably a normal residual plot to tell us if there's problems. Know how to look at those plots, know how to look if there's issues, review your output. Happy Quail, Agent Fox, Funny Emu, Honest Kitten, and Expert Wombat. Next question. Select the typical miss and variation explained in the output below. Hopefully I selected both answers. Which answers are they? I'll accept one error in a Kahoot, Brian, not two errors. So you need to find the typical miss and the variation explained. Typical miss. I'd only had 1 cup of coffee this morning while I was fixing things. Two appeals said. Okay, pretty good, pretty good. And we got both answers. So typical miss the models make is known as two terms. What are the two terms? You can give me the abbreviations for typical miss the model makes. As in, when I predict someone's height, I'm typically off using this model. I'm typically off by about 3 inches. So you can give me the abbreviations. What are the two terms for typical miss? Like it goes by 2 names. It's just called something different. It's like call me Brian or Bry. RMSE, root mean square error, right there. RMSE stands for root mean squared error. And then also residual standard error. Those are the same term right there. This thing right here, when I predict someone's height, because that's what I'm predicting, I'm typically off, or no, this is miles per gallon, I think, or something. This is miles per gallon. I made it this morning. When I predict the miles per gallon of a car, I'm typically off by about 3 miles per gallon, whatever, yeah, miles per gallon units. So it's the typical miss, and it's in units of the Y variable because it's how much you usually miss when predicting Y. When we see variation explained, blank percent of the variation in Y is explained by the variation in X, like 75.28% of the variation in miles per gallon is explained by the weight of a car, then we're talking about what right here? We're talking about what? When we say variation explained, as in 75.28% of the variation in, that's R squared. Now think about the interpretation of the intercept. When a car weighs 0, that doesn't make sense. Or among cars that weigh 0, we would predict on average 37.28 miles per gallon. Doesn't make sense, car can't weigh 0. How about the slope? 2 cars that differ in their weight by 1 ton are expected to differ in their miles per gallon by 5.344, where the car that weighs more is expected to get less miles per gallon. There's a negative relationship between weight and miles per gallon, where cars that weigh more are expected to get less miles per gallon. So once again, practice these interpretations. Know what every one of these numbers is. Tell me a number on the screen. Just like tell me 91.38. Tell me 19.858. Which number on the screen do you not know what it means? Some are less important than others, but is there any number on the screen you wonder right now what it means? I should be able to point to any number, significance of the model. This one we've only talked about briefly. I think I mentioned in class. It's more used for the multiple world. It's your R squared after adjusting for the amount of variables in the model, hence R squared adjusted, used to compare multiple models. Degrees of freedom for calculation purposes, not so important, but for a F or T distribution, tell you the shape of the distribution. I don't even think we ask you one time what a degree of freedom is on the test. They're more for calculation purposes. Residual standard error is known as RMSE, which is the root mean square error of the model, or the residual standard error, which is the uncertainty in the residuals. We have interpretation. The multiple R squared is the percent of variation explained in Y from the variation in X. It means also how, hey, Rita, good to see you there. Are there any questions on this? Point to a number, and you should understand every single number. Like the T right here is the ratio of the estimate of the intercept or the estimate of the slope over the uncertainty of the slope, known as the standard error, which the standard error of the slope is the ratio, or is the degree to how far we could be off from the truth, as in my estimate of the slope of negative 5.3445 could be off by about 0.5591. I'm not saying it is, but that is off by about that. It's a degree of uncertainty in your estimate of the value we're trying to get. The p-value right here tells us the significance of the slope, which is also the significance of the model in the univariate world. How would we use the t right there? The t is basically just used to calculate p-values because it's the probability greater than absolute value of t. So the t is just a ratio of the estimate divided by the standard error for that variable. 37.28 divided by 1.8 gets you about 20. And that's a very extreme t statistic, which is extremely statistically significant. So the t is used to calculate the p-value right there. The t is a standardized test statistic, which tells us a quantity of how extreme the value is. So that's a very, very unusual intercept in terms of how far it is away from zero. But more importantly, we care about the slope because the slope is the XY relationship. So the p-value of the slope is the p-value of the model. That p-value here is the p-value of the model, and it's also the p-value of the slope. You're welcome, Rita. So know your output, know how to interpret it, know what every single thing, every output we've shown in class, understand it. We focused a lot in our class on that, on interpreting output. Know what it means. Happy Quail, Agent Fox, Funny Emu, Honest Kitten, and Expert Wombat. Next question. Our estimate of the slope could be off by about how much? So if you were listening in, you should know the answer to this pretty quickly. Our estimate of the slope could be off by about how much? What is the answer? Let's see if people know. I'm hoping we get a lot of good answers. Let's see. Pretty good. We got about half, a little more than half right. What is the estimate of the slope? Just what is the estimate of the slope? Where is it? Just tell me what is. No worries, Rita. What is the estimate of the slope? Just tell me what it is first off. The estimate of the slope is what? What is the estimate of the slope? Well, that's not the standard error. The standard error is about how far off we could be in our estimate of the slope. The estimate of the slope is B1. So what is B1? Good work, Maya, right there. The estimate of the slope is right here. So that is the estimate of the slope. Now we could be off, JK, just trying to throw it out like that right there, JK. We could be off by about this much in our estimate. It's like if I said to you this, I'll meet you at 5, but I could be about 5 minutes late or early. What was the estimate of my arrival time? So if I said, I'll be there at 5, but I could be off by about 5 minutes. What was the estimate of my arrival time? It'd be 5 o'clock, right? Or AM, PM, what are we talking here? But I could be off by about 5 minutes is the standard error. Well, it's not 5:05. I shouldn't have used 5 for both of them, but 5 p.m., if that's what I'm saying I'll be there, is the estimate of my arrival. My uncertainty on when I will arrive is within and I'm not saying I'll be there within, what if I'm within 6 minutes? I'm saying about 5 minutes. That is my estimate of about how much I could be off. So we think the slope is 1.09, but we could be off by about 0.015. Now, we're not saying we are off by that much, but it's like when I'm saying I'll be there within 5 minutes of 5. I'm not saying I'll be there at 5:05 or 4:55. I might be there at 4:54, but 5 minutes is my metric of uncertainty. Does that make sense? Like, imagine this. If your friend says, I'll meet you at noon, but I could be a day late. You'd say, I'm not going to be there at noon because you've got this huge uncertainty window. You've got this big window of uncertainty. Like, do you really even know when you'll be there? You're like, yeah, I estimate noon, but I could be a day late or early. You're like, yeah, just tell me when you get there. But if your friend says, I'll be there at noon and I'll be within a minute, you're like, ooh, this person's, they're on the dot. They have very little uncertainty. Now, they could get there a minute and a half late or 2 minutes late, but if they've estimated their uncertainty properly, they should be there within probably 1 to 2, maybe 3 minutes, because that'd be a lot of uncertainty to go out 3 minutes if 1 minute is their metric of uncertainty. Does that make sense? Standard errors can also be known as what? Like residual standard error is how much uncertainty you have in the residuals. Standard error, the word I like to use for them, whatever we're talking about, like standard error of the intercept, standard error of the diameter, which is the slope, standard error of the residuals, is just a metric of what? I don't think of it as standard errors of whatever term. Just think of it as that U word I keep saying. It's just your amount of what in something. It's not always typical miss, uncertainty. Now, it is typical miss of the model when we're talking residual standard error, because residuals are your what? Residuals are your, use the word Maya used, great job Maya right there. Residuals are your what, so it is the typical miss, or about how much uncertainty we have in our misses, because residuals are how much your model what's by. So that's why that is the typical miss. So residual standard error is the typical miss. But be careful, there's not just one, residuals are the miss of the model, so the residual standard error is the typical miss of the model. where standard error of the diameter is the uncertainty in the estimate of the diameter. So be careful, standard error doesn't always mean typical miss, but it can always be proxied or talked about as uncertainty. So really good review right here. Write down each one of these, have examples in your notes, and you're on your one page. Happy Quail, Agent Fox, Funny Emu, Honest Kitten, Expert Wombat. Next question. What is the significance of the model? So we should be able to get this one pretty quickly. Significance of the model right here. Always look for a what. Whenever you hear significance, you need to go and find a what. Type in the chat if you want. Significance of the model. You need to go and find a what. Significance of the model. You need to find a what. P-value, Dom. Great work right there. P-value. And good practice, everyone. Boom. We did really well on this one. It is this value right here. It is also this value in the simple world, but look down here. That is the significance of the model. So the significance of the model is the p-value. And I want to say this once again, please look over the review sheet. It literally gives you everything on the test. It couldn't be more clear to me. So check it out, and I promise the test does follow it. Leaderboard, Happy Quail, Agent Fox, Funny Emu, Honest Kitten, and Expert Wombat. Next question. How many females would you expect to be left-handed? Remember, row total times column total over grand total. Have your calculator out. Try to do it. This is round 2 of doing it. Round 2 of doing it. You can also kind of cheat to see it. And remember, take a guess. You don't lose points for being wrong. If there's only like 3 seconds left, click a button. Not 3 seconds now, but have the calculator out next to you. Have your calculator for the test. Be ready. And if you want, type the equation in the chat. Nice. I'm pretty proud about that. I'm pretty proud. We got a lot more right answers. So what is the equation we would use right here? Like what is the math you did? How many females are left-handed? How many females would you expect to be left-handed right here? What is the math you did? Females left-handed. I've got a few redemption questions in here. Yep. And that is equal to 34. Row total times column total over grand total. Great job, Alyssa, right there. That'll give you 34 right there. So that is exactly, and whichever way you math it is good. But that will give you 34. And yes, let's try this one a little more difficult right here. What percent of females would you expect to be left-handed? Try to figure this one out. So this is a review from last time. What percent of females would you have expected? And so this is not how many, it's what percent of females would you expect to be left-handed? I can kind of tell, but try to figure that one out. What percent of females would you expect to be left-handed? Remember how we did it? This is Maya, I think that's right. Great job right there. So you would just go down here to the bottom, and the top up here doesn't matter because this is for everybody. We're talking about what percent. So you just say, well, if there is, and I should have said if there is no association, but that's kind of how we do expected. So 61 over 699. And so I was thinking it has to be less than 10% because that's, it's almost 700 and less than 70. So 61 over 699, what percent would we expect to be left-handed right there? Really good work and very good practice on these problems. Let's do another question. Happy Quail, Funny Emu, Agent Fox, Honest Kitten, Expert Wombat. Next question. Our observed variation is how many times larger than we would have expected by random chance? Hint, the last chi-squared was a 3/2. So we're looking at the same information from another test right here. And if you're stuck on this, let me explain it again. We just saw 3/2 because it was left, right, ambidextrous, male, female. So you have to use that information. Knowing that it's a 3/2, you have to know what to do with that. And what you will do with it is find the degrees of freedom. Since it's a 3/2, you reduce each one by 1. Type it in the chat. What are the degrees of freedom? So these are the steps to find how much more variation we see being explained than we would expect by random chance, which is actually less than we would expect here. It's the high p-value and low discrepancy. 3/2 has how many degrees of freedom? 3/2 has how many degrees of freedom? You have to find that first. 3 by 2 has how many degrees of freedom? The answer is 2 times 1, so what's the answer? Who knows? 2 degrees of freedom. So since there's 2 and does anyone remember the assignment on this? An earlier assignment in the semester had you do this. Check out the association assignment. This is why I pull questions like this. An earlier assignment in the semester had you do this. Petrie went over this in his video. A lot of people were asking about it during office hours. You take the degrees of freedom for the chi-squared, and this is what you only do for the chi-squared. So it was a 3 by 2 because left, right, ambidextrous, male, female, and then you delete one row, delete one column, 2 degrees of freedom, and you take the discrepancy and do what with it? Divide it by the degrees of freedom. What is 0.64 divided by 2? What is 0.64 divided by 2? 0.64 divided by 2 is what? So this is how you find 0.32. Why are we dividing by 2? Because the matrix was a 3 by 2, because there was 3 levels to handedness, 2 levels to gender, creates 2 degrees of freedom, 3 times 2, delete 1 from each, 2 times 1, divide the discrepancy by that number to find out the ratio of the observed divided by the expected. Everyone hear those steps again? 1, find the degrees of freedom. Rows minus 1 times columns minus 1. Right up there, 3 minus 1, 2, 2 minus 1, 1. Degrees of freedom 2. I could probably recreate it. It's the picture, because that's why I did that first question. It's from this data right here. So there we go. So here it is with 2 by 3. Don't use the marginal. But you can see here the 2 by 3 up here and the 2 by 3 right here. Do not use the totals. The totals do not count. When we say it's a 2 by 3, we're talking about this right here. 3 and 2. There's 2 levels to gender and there's 3 levels to handedness. So because of that, you would take the discrepancy right here, and what you're actually doing is you're taking discrepancy divided by rows minus 1 times columns minus 1. And so since the rows, I actually like the spaces. Since the rows are 2 rows, male, female, and the columns are 3, and you can see the math, whoa. That is 2. Oh, I know why. Darn parentheses. I think I did this. There you go. That's why be very careful. Have the whole thing evaluate. But does that make sense there, Major? I didn't have the whole thing evaluated. I divided and then multiplied, and that caused issues. You want the whole thing to evaluate right there. This is the degrees of freedom for 2 categoricals. It's different when you have a categorical variable. This is the degrees of freedom for 2 categorical variables. Alyssa, that is correct. And we won't talk too much about degrees of freedom otherwise, but you are correct. This is the degrees of freedom for 2 categorical variables, and how to know how to get a problem like this on the test that asks you for about how much bigger is the observed or the expected, is to divide this by the degrees of freedom. And I will say this, I think Petrie wrote one of the best tests we could possibly give you, because did you have a homework question that asked you for this exact same thing? Did you have a homework question that asked you for this exact same thing? Did you have a homework question that literally said, like, about how many times bigger is the observed or the expected when you were doing this for a chi-squared? Yes or no? I remember working on this with a lot of people. And with that, your test, no? Oh no! Well, we had this. And I will say this is very much towards Petrie and my test. So follow through with this. Know how to do it for these examples and what it means that this is actually not that large of a variation because p-value is high. And also this would be from the associate output with chi-squared. No worries, Adam. Definitely ask your teacher to confirm what is on your test. You might be using the exact same test as us, but this is the same material, so you're learning something there too. Thank you for being here. 100 points, Adam. But let us know if you have any questions, and then definitely confirm. Say, how does the test look? They should also have that posted right there. Okay, next question. Agent Fox, Happy Quail, Funny Emu, Honest Kitten, and Expert Wombat. Here we go. Which of the following shows the steps for solving the untransformed equation? Only solves for y. So here we go. What would you do? We have to solve for y, so an important thing to note is we want y solved for. So if y is raised to the half power in the transformation, how would you untransform it? So that's the key right there. Look at what happened to y. That's a key to solving these. Look at what happened to y. Does anyone want to say it in the chat? Remember to answer. If y is raised to the half power, how do you solve for y? So if y is raised to the half power, solving for y would require whatting? Y has been raised to the half power. So y currently has raised to the 1/2 power on it. How are you going to get rid of that? How would you get rid of that? Like if I were to say here, let me write this down. 2 seconds. People are saying in the chat, nice job. So what you have basically here, this is just partial solve of it, is y has been raised to the 1/2 power. So now you would just go here and square both sides. So because of that, it's now just, well, there you go. This cancels. Does that make sense? So once again, if y is to the 1/2 power, you just square it and then the x would keep it. So important to see right here, if you just take both sides, because if you square y, you have to square x, and then these would cancel right here. And since they cancel, you're left with just the other side squared. And usually what we're trying to do is solve for y, because then you can put it in a value of x and get the untransformed value of y. That then makes it a predictive model, predicting the units, not squared units anymore, of your variable or square rooted units. So with this right here, the goal a lot of times with untransforming models is to find what y is. So if y has been half powered, which is a square root, you square it to get rid of it. Good stuff right there. And whoop. Here we go with the next question. Let's do this. Agent Fox, Happy Quail, Funny Emu, Expert Wombat, Honest Kitten. Let's do this. What should we use? This will be up later. You got it. What should we use here? Now, the important thing to know is when choosing between Pearson and Spearman, you will pick one if there's major issues. If there's major issues, you will use Spearman. What are some of the things that would have us use Spearman? When would we use Spearman? When would we use Spearman? Nice work. This is a classic. And so this is a classic Pearson right here. Pearson really needs to look like this. It needs to be a linear relationship. That's something required for Pearson. It needs to have no outliers or very light outliers. There's nothing major here. This is very good. Classic Pearson, if you ask me. And if a statistician disagreed, I'd be like, yeah, this is classic Pearson. I'd be like, yeah. And should be linear, have equal spread, and have no major outliers. And then we'd use Pearson. If there's issues with linearity is nonlinearity, but it must still be what? To use Spearman, it must still be what? And let's kind of draw this out here a little bit, because to use Spearman, there is a condition that must still be met. What you're going to do is you're going to say linear. And if you say yes, you continue down this path right here. And you would then say no outliers. If you say yes, you continue down this path. And then you say equal spread. And if you say yes, you get to Pearson. So this is Pearson. And it should look at the end something like we saw. Or close enough to it. Depends on how big the issues are and how big your tolerance for issues are. But if you have nonlinear, you go over here and you say monotonic. And if it's monotonic and you say yes, then you will have Spearman. And so this is Spearman. That's Spearman. But the problem is if you say no, this is yes. But if you say no, then it's neither. Like a non-monotonic would be something that bends, and that's going to be neither. So we'll just say no, and we'll say neither. And over here, if there's outliers, it's just Spearman. And if there's non-equal spread, Spearman. So what you have right here is outlier issue would look something like points and then a big outlier, non-equal spread, points, and they start to fan or something. Does this make sense? Spearman is your fix for a lot of things. If there are outliers, Spearman is the way to go. If there's unequal spread, Spearman is the way to go. If there's non-linearity, I'm trying to make more of a bend in this data. Good to see you there, Annie. Took your class. Oh, thank you so much. Good to see you, Annie. So glad. I think I remember. I kind of remember. It's the thing is I didn't see people in class. I saw all the names. Thank you so much. That's a lot of positivity. I like it. And so if you look at this, what we drew right here, try to draw it out yourself. And remember that we want it to be a linear, no outlier, equal spread relationship to be Pearson. As soon as we run into problems, we go into using the idea of Spearman. But the thing required for Spearman, as Adam said right there, is it must be monotonic. It must be monotonic. If it's not monotonic, you're not using Spearman. You're using neither. Neither one right there. The good stuff. Next question. Let's do this. Leaderboard. Agent Fox on fire. Happy Quail. Funny Emu. Expert Wombat. And Honest Kitten. 2 more questions to go. How many tests are failed? This is your redemption on the tests. How many tests are failed? Should be a quick and easy one if you know how to check tests being failed. Have this note. Write down the notes. How do you know how many tests are failed? How do you know how many tests are failed? Tests are failed on the check regression when the p-value is low. That doesn't mean p-value is low or bad. It just means when we're checking regression, p-value is low means a problem with the condition. Every single test was failed. Why is every single test failed? Walk through it with me. You ready? P-value for linearity below 0.05 failed. P-value for equal spread below 0.05 failed. P-value for normality of residuals below 0.05 failed. Each one of these is failed. We would need to look at the plots to see if there's issues. I think the last one's kind of a fun and easy one. So any questions on this? Pretty good job right there. I was hoping everyone would get it right. But you look at each one of these p-values and you see if they're below 0.05, and that means there's an issue with the check regression. So low p-values are bad in general. Yes or no? Low p-values in general are bad. Low p-values in general, just like a low p-value is a bad thing. No, it depends on the context. No. It just depends on what we're trying to do. It depends on what we're examining. What are you looking for evidence for? It means if the p-value is low, it means you found evidence of that, or evidence for the alternative. So we have evidence for the alternative, and the null is that linearity is good, so we have evidence linearity is bad. So we need to look at our plots right here. Remember that. So we get to the leaderboard. Agent Fox, Happy Quail, Funny Emu, Honest Kitten, and Expert Wombat. Last question. Diligent Bunny trying to come back, though. Here we go. After we fail a test, what is the next step? Let's see what people say. It's almost that time. The end of the Kahoot. And he's back. He's back. Who's back?
I'm back. I'm Tiny Brian. Good to see everyone here. Tiny Brian, time for the leaderboard. Let's do it. In 3rd place, it doesn't do the thing anymore. Funny Emu. Make sure to come get your Kahoot t-shirt from Brian or your Kahoot t-shirt. Second place, email Brian for Starbucks or Amazon Agent Fox. And in first place with an amazing lead, Happy Quail. Make sure to email Brian for your Starbucks or also Agent Fox as Rob. No, back to regular Brian.
Okay, as Tiny Brian was saying right there, make sure to email me for your Amazon gift card or your but actually Happy Quail and Agent Fox both get either an Amazon gift card or Starbucks gift card, $20. Make sure to say which one you want, let me know. But that's got it. That reindeer cap was a very, very good, a reindeer hat, very good. Oh, it's a fox, that's a cool looking fox right there, Happy Quail. So amazing work, everybody. Does it not show? It used to show one more screen after this. Where's the end screen? Where's the end screen? Does it not got an end screen anymore? It just stays on the screen forever. I don't know where they took away their music and stuff. Maybe they took it away because I kept getting copyright claimed on it. I don't know why they don't just make their own music then, but I would have issues where it would copyright claim me. So maybe there was something to that copyright claim. What questions are there? I'll hang out for a minute more, but let's over to the main screen. What are people wondering? Just to show me, I want to look at how the Kahoot went. Be able to look at it. Change is not saved. It won't let me exit the Kahoot. You're welcome, Hannah. Excellent work. I'll leave the Kahoot. Hopefully it saved it. Home. Kahoots. Where is your Kahoots? Reports. Yes. 36 players to start. Okay, when people leave early, it's a bummer. Unanswered. A lot of people start and then leave. I don't know if they get discouraged or what. What do you think is the hardest part of the computational exam? I would say just knowing how to read output. Good question, Z, right there. Knowing how to read output can be very tough. Knowing how to read output can be very tough. So read the output, know how to read it all, go back, watch the videos, and know how to read all the output. So, Scatterplot 1 was, very few people got everywhere on the scatterplot. Only 3 people got everywhere on the scatterplot. So that's really where knowing heteroscedastic, homoscedastic, linearity, non-linearity, like have a check for each one of those. So the scatterplot wording was a very missed question. I observed a lot of people missed that one, yeah. The most correct answers were, oh, that's the one I got wrong. After we fail a test, what's the next steps? Well, with that, we're no answer. No answer. No answer. Well, we're gonna head off. We'll be back here with school. But until then, bye for now, everyone. Bye. It'll be back on. Mubot talking away. Mubot, what are you doing on the screen? Mubot talking over me. This will be up. It'll be recorded, and you can watch it afterwards. Bye for now.